So for this month, I ended up being able to implement the algorithm for a decision tree to solve a binary classification learning problem. A binary classification learning problem is a learning problem that tries to predict a simple yes or no response. So we're trying to build a system given a student with past records and a new course would guess whether that student would like the new course. So that's it. That's what we are trying to build. And we are going to implement that using a decision tree. So let's go ahead and take a look at the algorithm. Here's a training data that we're going to use. So what does this table mean? Let's take a look first at these things above here. So we have here easy, AI, sys, I think this is systems, THY, I'm not sure what that means, and morning. So these are questions regarding or pertaining to a course. So if we take this one column here or one row, a single row is a collection of answers to each of these questions pertaining to a specific course. So the answers here are just like yes or no. And also it contains whether the student enjoyed that course or not. Here, enjoyed is measured by these numbers from 0 to positive 2 and 0 to the negative side. So everything from 0, let me just put this back here. So everything from 0 to positive 2, we'll just label it as liked. So, and ratings below 0 falls to disliked. And so in this table, we can call the questions as features. And then the responses of these questions, whether, for example, in this case, is the subject or the course easy? The answer is no. And we can call the answers as feature values. And then the rating, we can call it the label. So it could either be liked or disliked. Informally, the first step is we would like to see the frequency of like or dislike labels for each possible value of an associated feature, and it can be easily represented by a histogram. So looking at this histogram, I will show you later how we can derive the numbers in this histogram. But looking at this histogram, if we ask the first feature, is it easy? So that's the first feature. If the value is either yes or no, it's kind of ambiguous to us whether the student would like it or not. If the answer is no, the student is more likely to like the course because it's 60% like. But then also when the answer is yes, the student is still more likely to like the course. On the other hand, asking the second feature can provide us some usefulness. So the second feature is asking whether the course is AI. So if the answer is no, 33% of the data here falls under like, 60% falls under hate. But on the other hand, if you're going to inspect the second feature, which asks whether the course is under AI or not, if the answer is no, 33% falls to like, 66% falls to hate. And then on the other hand, if the answer is yes, 82% falls to like and 18% falls to hate. So with the second feature, it somehow provides us some usefulness, because say if the value of, or if the answer to the question is no, there's kind of an intuition that there's a bigger possibility of getting a hate label. And then if the value is yes, there's a huge implication that the student is likely to like the course. Now let's proceed to how we can derive the values on this histogram. Let me just take this out first. So we are going to actually consider each feature or each question. Let's take a look first at the feature asking, is the course under systems? Let's put a box in that. So from this feature, we will call the set of training examples with the response of no as the no set. So we will have the no set, and we will also have the yes set. So again, training examples with a response of no falls in this set, and training examples with a response of yes falls in the yes set. From our 10 examples in this table, looking at the third feature, which asks the question whether course is under systems or not, we are going to count how many responses fall under the no set and how many responses fall under the yes set. So if you count them, in the no set, we have 5 responses. And we also have 5 yeses. So we have 5 responses falling under the yes set. Now, if we take a look at the yes set, so from these 5 training examples, how many examples fall under the label liked? So we have here, this is the label. So this one is hate. So from these 5 training examples under the yes set, in the third feature, how many fall to the label like? So there are 5 yeses and only 1 out of 5 falls under the label liked. So from these 5, we have 1 like, and we have 4 hate. Looking at the no set, again, the same thing. From these 5 training examples, how many fall under the like? We have 5 of them fall to like, and 0 falls to hate. So if we are going to create a histogram to depict this data, it would look like, so this is the feature, and if the response is yes, if the response is yes, 1 out of 5 is like, so that is 20%, and 4 out of 5 falls to hate, and that is 80%, right? And if the answer or the response is no, like 100% goes to like, put it here, 100%, and 0% goes to hate. So this one is like, hate, like, hate. And that's how we derive the values in the histogram. For this specific feature, we now know what we would guess if we had to. So for example, if the response is yes, then we would guess that the student would hate it. So let me just write that down. For the features systems, if the answer is yes, then our guess is what? Hate. And then if the answer is no, our guess is then like. Next thing we would do is we compute the score we get for this feature. What we are trying to do here is we're going to compare our guess, like how good is our guess compared to the actual data that we have, and compute the score for that. So if you're going to take a look at the no set, our guess for the no response is the student would like the course, right? So if you're going to compare that against the actual data we have here, so in the no set, if we take each training example one by one, so we have this, and our guess is that it falls under like, and then if we look at the actual rating, yes, it does fall under the like. So then we have one correct guess. And if we do that to all of the training examples under the no set, then we would get 5 out of 5 correct guesses. And what about the yes set? If the response is yes, our guess is hate, right? If you're going to take each training example under the yes set one by one, so take this one. So my guess is that the student would hate it. But the first training example, the student end up liking the course. So we got that wrong. And then for the following training examples, if you take the second one, okay, there's another yes response. Our guess is that the student will hate it. And the actual data, the student actually ends up hating the course. So then we got that correct. And same thing goes to the other training examples as well. So at the end of the day, for the yes set, we will get 4 out of 5 correct guesses. So computing the score for this, we will get 9 out of 10. So we will then repeat this computation for each available features. So we just basically need to do the same thing for each feature here. And then this will let us know which feature to ask first. And that feature that has the best score will be the feature that goes in our root of the decision tree. So it will come first in the root of our decision tree. So this will be the feature with highest score. And all of that process is summarized in a pseudocode, which happens to be in the book as well. And in fact, let me just pull that here, clean this thing up, and put the algorithm up. So it's just a recursive function which does what we did earlier. And I also was able to implement the algorithm. There's still a lot of room for improvements with regards to my code, but I just wanted to get it working. So what this function does is take a set of data, the training examples that we have, and then use it to be able to come up with a tree. So if you're going to run this, yeah, we'll come up with, it's just an object which represents a tree. And if we're going to represent this as a tree, we will come up with something like this one. So this is the tree. So for example, you're given a course, and then you will just ask whether the course is under systems. If it is not, then is it AI? And if it is not AI, then our guess would be the student will hate it. On the other hand, if it is AI, then you would ask this question pertaining to that same course. And if the answer is no, then hate. And if the answer is yes, then like. From the root node, if the course is under systems, the model that we have basically just gives us like a guess that the student will likely hate the subject. Basically, our model, because of this, the frequency of no responses and the equivalence of these responses as liked, and also the frequency of yeses to not liked or being hated, the model kind of generalized that if the course is under systems, then the model is basically pretty sure that the student will likely hate the course.